Okay, let's get started. It's great to be here at the 7th OCP Summit. I'm sure you've been enjoying the conference so far. There were some fantastic keynotes in the morning, and then the exec tracks have been pretty exciting too. So what I'm going to talk today about is what innovations we are driving in the cloud at Hyperscale, and I'll go into a little more detail into the contribution that was announced this morning in the keynote, which we called SONiC, Software for Open Networking in the Cloud. So we'll kind of deep dive into what that is and how it works, what are we contributing, what is the innovation, how does it help OCP advance the agenda in networking, and so on. So let me first briefly introduce myself. So I'm Kushagra. I'm the GM for hardware engineering at Microsoft, and so I run the team that does the research and engineering for hardware designs that are deployed across Microsoft's cloud, including Azure, Bing, Office, Xbox, and so on. As we've been part of OCP since 2014, so we'll take a brief look at sort of just for folks who might be new, kind of just a quick run through what we have done so far and how that ties back into the larger OCP ecosystem. So back in 2014, in January, Microsoft joined OCP, and we contributed all the collateral, hardware, software, schematics, Gerber files, CAD drawings, you name it, for our server infrastructure, which we called Open Cloud Server. So this was, there's a visual on the screen there of what it looks like. It's a 12U chassis with server blades in it, up to 24 blades with a shared power backplane, shared management, shared cooling. And this is what we are using for deploying across the Microsoft Cloud. Then later that year in October, at the OCP Summit in Paris, we followed up with a subsequent contribution for what we called OCS V2. This was essentially Intel's next generation CPU, so we contributed the collateral for that. Additionally, we also made contributions in this framework for networking and storage. We were the first ones to come to OCP with a 40 gig network solution which had support for routable RDMA. So that was this is back in October 2014. And the other thing we did at the time was we submitted a specification for a new kind of flash device, basically a PCI Express based NVMe, M.2. M.2 is typically the form factor that is for SSDs in your laptops. So we took that commodity form factor, brought it to the cloud, and we made that contribution. And that's what we deploy today in all our flash deployments in the cloud. Then last year in 2015, for those of you who are here, we made another big contribution for what we call the distributed battery. This is a power supply that has a built-in battery, and it allows you to cut the cost of the data center the data center UPS cost by 5x. So this was a huge evolution in data center backup and power systems. And the data center footprint reduced by about 25%. And this is what we're deploying in our cloud services today. The other contribution we made back then, and we'll touch upon this in a little more detail as we go through the networking contribution this year, was the switch abstraction interface. So think about so today you have switches, and the software stack on the switch is very tightly coupled to the ASIC, the networking chip that's in the switch. And what we wanted to do as part of driving innovation in OCP was to disaggregate these two layers. So the switch abstraction interface essentially is a hardware abstraction layer, which is an open API, and so that you can pick your favorite ASIC supplier and still have the same interfaces to talk to that ASIC. So this allows you to pick. I think we have support from several switch suppliers today, switch ASIC suppliers today, but the same programming interfaces will work on all of them. So this was a big evolution forward in disaggregating the network switch. And then this year, these are contributions that we have made to OCP. This is a continuous evolution of the hardware platform. So Intel's next generation CPU, which will be announced soon. The servers for that, the collateral is all in OCP already. If you go to the OCP wiki, you'll find all the documentation there. And we also contributed a full width server. This is for workloads that require commodity storage and up to 10 hard drives in a single form factor. The other contribution we made this year, earlier in January, was we upgraded the chassis manager. So there were more features for system manageability, debuggability, serviceability, and it also upgraded the CPU. So that aside, so let's get into the kind of what does this mean in the bigger picture. So it's good to have those contributions, but how do they come in? How do they all come together? So OCS, which is Open Cloud Server, what I just showed you, this is the infrastructure that powers Microsoft's cloud. Over 90% of servers we buy today are based on the OCS specification. So we're driving it at that scale. And these servers are modular enough to accommodate a variety of workloads, anywhere from public cloud to cloud gaming, to Office 365, to internet search. All of that can be accommodated on this common architecture. At the same time, they are deployed globally. So we have 22 regions worldwide, different operating environments, different electrical standards, different heights, different environmental parameters. The servers can operate in different colo designs. So it gives us that flexibility to scale globally and to scale across workloads without having to re-architect the base platform. It's designed to do that. So this is kind of what we're driving at scale. So let's go a little deeper into the network part of the announcement, which was made earlier today. So just to recap what was mentioned in the keynote, just to sort of level set so that we can go deeper. Here's a visual that shows you how the OCP networking stack is set up today. Of course, at the bottom of the stack, you have the OCP hardware, the switch itself, the switch chassis. On top of that, you have Open Network Linux, ONL, which is OCP's Linux-based solution for networking. And there's ONI, which is for provisioning the switch, for bootstrap provisioning. And then there's a switch abstraction interface on top, which is the abstraction for making the switch ASIC agnostic. I just talked about that. So the piece that was missing is there is no open source components available in OCP today to complete this picture of a fully disaggregated network switch so that you can do all the typical switch functions, routing, configuration management, state management. So we didn't have those pieces. And that's where the contribution that we made today, along with our partners, comes in. So we're calling this Sonic, software for open networking in the cloud. And what it basically is it's a contribution that's based on a production deployment at Microsoft. So this is not test software. It's running at in a data center already, taking production loads. It's a contribution with our partners, with Arista, Broadcom, Dell, and Mellanox. So we are building a community around this so that we can encourage innovation in OCP through a community. It runs on top of a Linux distribution. This would be Open Network Linux, for example. In the future, it's conceivable that there'll be other Linux distributions from existing Linux suppliers who will be compatible with this framework. And essentially what Sonic is it's a collection of network software components. I'll go into more detail on this one. So let's start by kind of understanding what it is and what it is not. So like I mentioned, these are software components that sit above the abstraction interface that perform the key network functions such as routing and so on. It is 100% open source, and this is the first time that we have a fully disaggregated network stack in OCP that is completely open source. So this will drive agility and innovation across all of the OCP community. So we are very happy to see that happen now. It's going to be supported by the broader OCP community. We have 5 partners today, and we expect those partners to keep growing. And it is real. It's deployed in a production deployment. We have tested this at scale, and we'll continue to drive more features in this over time. I want to make sure people understand what it is not at the same time. This is not a distribution of Linux. We leave that job to the guys who do Linux best, the companies who are in the business of selling Linux, or ONL, which is part of OCP already. So we build upon that framework. We don't want to reinvent that framework. This is the higher level of the stack. There is no hardware involved in this. This is all software. The idea here is to reuse the hardware that's already out in OCP, the OCP switches that have been contributed around the OCP website. And of course, this is not prototype software. It's not something that is kind of a test thing that was run in the lab. So let's start to deep dive a little bit into what exactly comprises of Sonic. So what you see here is three color codes. The first one is what's in green, which is what is the contribution that is being made by Microsoft and its partners. What is in blue is what are existing open source components that are already out there that we chose to reuse so that we can build upon the good work that's already happened in the open source community. And the yellow are some ideas of how the community can take this contribution and continue to build upon it and extend it. So let's start going through each of these in detail. So the biggest part of the contribution on the green side is what we call the switched state service. So this is the piece of software that interfaces with the SDN control plane that is responsible for setting up the routes. And you see that there is a Redis database that is used to hold the route, so we kind of reuse that component. This is the piece that programs the switches, the switch ASICs using the SI interfaces. This is where all the action happens. And to this date, there is no open source software available for this switch management and switch setup and switch functionality such as routing available. So this is the first time this is being made available to OCP, and this helps in disaggregating the network stack and driving that open source ecosystem that we need. And the second piece that you have is platform drivers. So this is where our partners have made a contribution. So think about a switch made by Arista, Broadcom, Dell, or Mellanox. So you will have platform-specific drivers that need to be in the solution so that the software can run on these different platforms. So those drivers are being contributed by our partners. And then you have utilities and support for how do you manage the switch. So you took care of the data plane. How do you manage the switch? So those components are already also included, and this includes command line interfaces and SNMP. So this is the contribution that's being made. And then the other thing we did was we took existing open source software such as Quagga for BGP, the Redis database for storing the tables, LLDP and the link aggregation protocol pieces from the open source community, and then put it all together into one holistic package, made sure that the integration was done such that it was actually working in a production environment. And then the APIs were defined such that it could work on top of SI, and that you could also have configuration management software running on top of this. So for example, we kind of anticipate in the future IT enterprises or other cloud operators who have their own system management or system provisioning interfaces, APIs, they can pick this up and extend it. They can create their own plugins and then interface with this switch architecture so that it's completely extensible in that way. So this allows us to kind of have one common solution in OCP, which is not only fully open source, but is extensible to how you want to use it in your deployment, right? So that's the key part. So let me kind of just sort of look at where would we take this in the future. And this would be where the OCP community, in fact, would be a key part of building out this overall infrastructure. So imagine a few years out as this ecosystem builds up, and we get more and more contributors from OCP building on top of this switch stack. So if you are an OCP end user, you will be able to, at that point, say, I want to use this switch ASIC. There's a couple of companies listed there. You pick your switch ASIC based on what features that switch ASIC has. Then you pick your switch chassis. You might want a 1U, you might want a 1RU, you might want, maybe there's some power supply differences, but you pick your switch chassis. It's up to you, right? Then you pick your OS, the Linux OS, and the installer environment. Today there's ONL, of course, in OCP. Over time, we anticipate other Linux distributions will be available, which will be interoperable with this environment. But you pick your favorite OS environment. Then the role of the system integrator or the solution provider would be to make sure that these different pieces are put together. The switch ASIC, the switch chassis, and the OS installer environment, they will put it together. They'll make sure that it all interoperates and is tested. And that's your switch solution that is customized based on your requirements. Then on top of that, you put the Sonic framework. So now you have the higher level network stack. So there's three pieces there. The first one is the software that is being contributed today, which provides you with all the basic functionality that you need to get a switch up and running. I mean, we are using this functionality in Azure, in our production networks, so it's fully complete. But then, what we have may not be necessarily the right fit for you, because you may have a different IT environment, different management interfaces, different ways of deploying your applications, and so on. So then you go and write your own plugins. It's all open, right? So you write your plugins, or you can source a plugin from some other open source effort, but it's entirely up to you. You bring your own software components, and you extend this open source project to make it sort of a bigger ecosystem. And this is how the OCP network stack continues to grow and become more extensible. And over time, you'll see more and more options available. In the end, what will happen is, there is a fully open source switching platform, and it gives you a lot of choices to meet your requirements for your data center. That's kind of the goal of this effort. And the best part about this is that it will be driven by the OCP community, which is all of you. So you can come in and shape it the way you want it to look like for you and others. So this is we are very excited about this contribution, and we would encourage you to take a look at this and be part of the OCP networking committee and start to help the community to build upon this, and to help bridge the gap between what the network switches we have today and this open source network switch. One thing I want to mention here, which is sort of, you might be thinking, why is Microsoft doing this? What's in it for Microsoft, right? And so there's two things here, right? One is that we get to have faster agility by taking what has been proven in the open source community. I mentioned in the previous slide what was the blue components, like Quagga and so on. So we take the good pieces from the OCP community, and we build upon it and give it back to the FC community. So essentially, that gives us the agility to get our solutions to deploy faster. So agility is key in the cloud. So that we benefit from that in the cloud. The other thing that helps in this regard is the reason we joined OCP in the first place back in 2014 was so that we can help to bridge the gap between the public cloud and enterprise. Microsoft is uniquely positioned to do that because Microsoft has a presence in the public cloud by virtue of Azure, and it has a presence in enterprise by virtue of Windows Server and so on. So our goal is to figure out how do we drive this consistency between the public and the enterprise, so that we can create that common consistency of technologies. We learn from the public cloud and we trickle it down to the private. This fits in that vision. As you can see, as we learn at scale, we'll continue to contribute to this. And then the enterprise customers who want to build upon that, they can take this and they can adapt it to fit in their environment, working with their solution providers. And that helps to have a common ecosystem in the networking space. On the server space, OCS does that. On the networking space, Sonic does that. So it helps to kind of bridge that whole hybrid cloud vision that we want to make sure that happens in the industry. So just to kind of wrap it up, there's a lot of innovation that's been driven at scale. Over the years, we've been driving contributions and innovation across three vectors: servers, storage, and networking. We talked about the server piece, the UPS, and the server chassis, and the server blades. We talked about storage, where we have the JBoard, and we have the storage server, and you have the SSD, the commodity SSD that has its roots in the consumer space, but it's adapted for the cloud. And then now you have networking, where it helps to disaggregate the network, as we just talked about. So the vision we have is that we take the three pieces here, and we bring it together, and we use those to drive innovation through OCP and help to bridge the worlds between the public and the enterprise. So thanks for attending. I'm glad to be here and present our latest contributions to the CP community. I hope you find this useful and that you'll find a way to use this and take it forward from here. Thank you.